Welcome back everybody. So, how's you all? In today's video, we will learn more about gradient descent and linear regression for for linear regression. So, here's the linear regression algorithm and here's our gradient descent algorithm. So, we have h of theta x. Wait a minute, here x will come. Sorry, I forgot all the times to put a x here, or maybe their problem. So this is our formula. J of theta is equals to 1 over 2m. Here's the summation all your means that summation is sum of all the quantities when the values are changed, like I is equals to 1, I is equals to 2, 0 and up to m. So here's our formula, h subscript theta xi. So we will change I here, so as I have taught in the earlier lectures. So we can interchange the value of h subscript theta xi here, this value. But in the gradient descent, what we does is we write this statement here: theta j is equals to theta j minus alpha times partial derivative with respect to theta j of we can say theta j here, because we are putting for j is equals to 0 and j is equal to 1. So this is our algorithms. So now let's see what will be the derivative. So we are derivating 1 over 2m h subscript theta x minus y to the power 2. So here, wait a minute, in the superscript I will come, and here too. So this is the algorithm like the previous one here what we have write, but I have removed the summation because it is clear that we are taking 4 specific examples, so summation doesn't required here, and here is power 2. So what I will do is wait a minute, first of all I have to express this thing into its full form. So what I mean by that is 1 over 2m theta 0 plus theta 1 xi minus yi to the whole power 2. So now when we derivate it, partial derivate, so if we derivate it with respect to theta 0, so obviously theta 1 will be here equals to 0, because we will be taking j equals to 0. So j equals to 0. So then this term will not be there. So the derivation will be not much complex, 1 over 2m theta 0 minus yi to the power 2. Nothing will change. So I advise you all to kindly note this thing down on a paper or in your notebooks. So this is with respect to theta 0 of j of theta 0. So this is the derivation. So now let's erase all this thing. Now when we put j equals to 1, then theta 0 term will not be there, but theta 1 will be equals to theta 1. So this will be, derivation will be 1 over 2m and theta 1x plus, sorry, it's my mistake, here it will come minus y to the power 2. Now you all will ask, what's the difference? Here 2 times x will come, because the power of 2 derivation 2 will come here. And if you do not know derivation much, then do not care about that, just write what I am saying. So wait a minute, here there is a problem. What's just happened? Yes, it's okay. Oh, now it's here. So here this term will not come, because when we derivate say x to the power 2, then its derivation is 2x. So the power comes here and minus 1 comes here. So this is a simpler way to make you understand. So do not worry if you do not know about this. So now let's move on. So now let's talk about what is convex function. A function, it is a function which doesn't have local minima or maximum. It just have a one minima. One minima. No local minima. Only a single global minima. So what our function does is same thing, but here in this case there are no chances that we will reach any other minima. So sorry about this thing that it is overlapping this area, because it's hard to tell in a 2D diagram about 3D things. So do not just take this, do not think more about this. I have told you that it is from inside. You have all seen bowl, so it's the inside area of the bowl. So this is, wait, just let me write inside. What just happened? Inside area. So these crosses are inside the curve. So this was the last topic of today's lecture. So before you all goes, thanks for such increment in the subscribers, and I say continuously about views and much, but it helps me emotionally, and it satisfies me that somebody is learning from me and I am doing something great for world. So that's all for today. Thank you for watching. See you in the next one.